Hello everyone, I hope you all are well. In this video, we'll discuss problem question based on binomial distribution. So let's begin. The mean of the binomial distribution is 20 and standard deviation is 4. Calculate the parameter of its distribution. So in this question, we are given mean of the binomial distribution and we are given standard deviation. We have to find parameter of its distribution. Parameters are n and p, right? So here we are given with mean equal to 20, standard deviation equal to 4. In case of binomial distribution, mean is given by n into p, right? So n into p is equal to 20 and standard deviation. What is standard deviation? Standard deviation is under root of variance, or we can say variance is square of standard deviation, right? So standard deviation is given 4. So we can put standard deviation equal to 4. So variance will be equal to 4 square. And variance in case of binomial distribution is given by n into p into q. So n into p into q is 16 and n into p is equal to 20. We have given this as equation 1. We have given this name as equation number 2. So now what we'll do, we'll put equation 1 in 2. So putting equation 1 in 2, we get, instead of np, put here 20. So we'll get 20q equal to 16. And from here, q will be equal to 16 upon 20, which is equal to 4 upon 5. And what is the value of q? Q is 1 minus p, right? So 1 minus p is equal to 4 upon 5, and from here p will be equal to 1 minus 4 upon 5, which is equal to 1 upon 5. So p is equal to 1 upon 5. Now we want to find out n. What we'll do? We'll put the value of p equal to 1 upon 5 in this equation 1. So when you'll put p equal to 1 upon 5 in this equation, we'll get n into 1 upon 5. Taking the 5 the other side, we'll get n equal to 100. So parameters of binomial distribution are n equal to 100 and p equal to 1 upon 5. Next question. With the usual notation, find p for a binomial variable x if n is equal to 6 and 9 times probability of x equal to 4 is equal to probability of x equal to 2. So we are given n and we are given this condition. We have to find out p. So we'll use this condition. Okay. So using this condition, we'll substitute the value of p4. P4 will be equal to nc4. P raised to power 4, q raised to power n minus 4. And p2, in case of binomial, we have nc2, p raised to power 2, q raised to power n minus 2. Now we'll put the value of n is given here. So we'll put the value of n. So this gives us 9, 6, c4, p raised to power 4, q raised to power 6 minus 4 equal to 6c2, p raised to power 2, q raised to power 6 minus 2. Next, we'll just solve these equations. So 6c4 can be written as 6 factorial upon 6 minus 4, 2 factorial into 4 factorial. p4 into q raised to power 2. 6 minus 4 is 2. 6c2 can be written as 6 factorial divided by 6 minus 2, 4 factorial into 2 factorial. p2 q raised to power 6 minus 2, which is 4. So q4. Now this 6 factorial, 2 factorial into 4 factorial can be cancelled with this 6 factorial into 4 factorial 2 factorial. So we will get 9 p square. How we are getting p square? P raised to power 4 can be cancelled with p square. We'll be left with p square only. So 9p square equal to q square. q4 can be cancelled with p square. So we'll be left with q square. Now we'll put the value of q equal to 1 minus p. So putting q equal to 1 minus p, we get this. Now we'll open up this square. After opening the square, we get 9p square equal to 1 square plus p square minus 2p. We are using a minus b whole square formula here, which is a square plus b square minus 2ab. Now we'll just solve this equation. This will give me, if you take p square this side, 9p square minus p square, you get 8p square. 2p you take the other side, it will become plus 2p, and 1 you take the other side, it will become minus 1 equal to 0. This is quadratic equation in p, and we'll solve this quadratic equation using discriminant method. So p will be equal to minus b plus minus under root 2 square minus 4 8 into minus 1 upon 2a. To find out the whenever we have quadratic like this, ax square plus bx plus c equal to 0. How do we find out x? X is equal to minus b plus minus under root b square minus 4ac upon 2a, right? So here you can see b is the coefficient of x. Instead of x here we have p. So coefficient of p is 2. So minus 2 plus minus under root b square 2 square minus 4a. What is a? A is coefficient of x square. So coefficient of p square 8 into c. C is the constant term. Here the constant term is minus 1 upon 2 into a. 2 into a. A is 8. So we have just used this discriminant method to find out the value of p. So now we'll just solve this. This will become 4 plus 32. So minus 2 plus minus under root 36 upon 16. Okay. Now under root 36 is 6. So minus 2 plus minus 6 upon 16. Now we'll solve this. This is minus 2 plus 6 upon 16, or minus 2 minus 6 upon 16. This will become 4 upon 16 or minus 8 upon 16. So which will be equal to 1 upon 4 or minus 1 by 2. Now value of p cannot be negative. So minus 1 by 2 is rejected. So we'll get p equal to 1 by 4. So we have to find p for the binomial distribution. We got this answer. Next question. If on an average 1 ship out of 10 is wrecked, find the probability that out of 5 ships expected to arrive the port, at least 4 will arrive safely. So if the ship is wrecked, it will not arrive safely, right? So probability of success, we have to find out. Probability of failure is given, right? If it is wrecked, it will not arrive safely. So we are given q. 1 ship out of 10 is wrecked. So we are given q equal to 1 upon 10. And p will be equal to 1 minus q, 1 minus 1 upon 10. So 9 upon 10. Then we have to find out at least 4 will arrive safely, which means we have to find out p greater than or equal to. At least 4 means minimum it should be 4, maximum it could be anything, right? So we have only 5 ships, so maximum is up to 5 only. So 4 and 5, probability of 4 plus probability of 5. So we'll apply binomial here. So we have p equal to 9 by 10, q equal to 1 upon 10, and we have n equal to 5. So we'll use binomial here. So 5c4 p raised to power 4 q raised to power 5 minus 4 plus 5c5 p raised to power 5 into q raised to power 5 minus 5. Opening this 5c4, we get 5 factorial into 5 minus 1, 4 factorial into 4 factorial. Putting p equal to 9 by 10, putting q equal to 1 upon 10, 5 minus 4, 1. Plus 5c5 is 1, right? P raised to power 5. P is 9 by 10 raised to power 5. Q raised to power 0. Anything raised to power 0 is 1. So this term will be alone. Now 5 factorial can be written as 5 into 4 factorial. 4 factorial will be cancelled. Will be left with only 5 here, and from these two terms we can take out common 9 upon 10 raised to power 4. So we'll take out common 9 into 10 raised to power 4. Inside we'll have 5 into 1 upon 10 plus 9 upon 10. Now this is 5 upon 10 plus 9 upon 10. Calculating this will get 14 upon 10. Okay, and calculating this whole value will get a probability of x greater than or equal to 4 equal to 0.91854. So probability that at least 4 will arrive safely is equal to 0.91854. Next, if you are given data, then how you can fit a probability binomial distribution to that given data. So there's a method to fit binomial distribution to given set of data. Like suppose if you are given this data, you are given x and you are given frequency of this, and you have to fit binomial distribution to this data, then how you will do? So the first step is find mean of binomial distribution, which is equal to NP, and the value and the method to find out mean is equal to summation xi fi upon summation fi, right? So we have f, we have x, we can find out mean from the given data. So here mean will be equal to summation fi xi upon summation fi. Let's just multiply these two things and add them. So 0 into 28 plus 1 into 62 plus 2 into 46 plus 3 into 10 plus 4 into 4 divided by summation fi. Summation fi is 28 plus 62 plus 46 plus 10 plus 4. So this gives me 200 upon 150, which is equal to 4 upon 3. So this is mean of this data, and mean in case of binomial is given by n into p. So n into p is equal to 4 upon 3. Let's see the second step. Second step is find p for given n or n is taken to be 1 less than the number of variables given. So now next we'll find out p, taking either n will be given or we'll take n 1 less than the total number of variables. So here n is not given, but total number of variables are 1, 2, 3, 4, 5. 5, so we'll take n equal to 4. So for finding p, we can find out p from here. P will be equal to 4 upon 3n. N we are taking as 4. Right, so this is equal to 1 upon 3. P is equal to 1 by 3. So Q will be equal to 1 minus P, 2 by 3. Next step, find capital N, which is summation Fi. So capital Fi, summation Fi is equal to 150. This is the value of capital N. Next step, find expected frequency given by this formula. F of x equal to N into P of x. And x will vary from 0 to n. Okay, and capital N we know small n we know x will vary from 0 to n, we know p and we know q. So we can find out all these values using the given things, using the things we have. So we'll make this table, this kind of table. Here the value of x, here the value of expected frequency. This is the theoretical value which we are calculating here. This is the actual frequency which is given. So for x equal to 0, capital N is 150 into 4C0 p raised to power 0. P is 1 upon 3. P raised to power 0. Q raised to power n minus x. So 4 minus 0, 4. So after calculating this, we'll get 29.6. Similarly, for x equal to 1, capital N into 4C1, P raised to power 1, Q raised to power n minus x. 4 minus 1 is 3. After calculating this, we'll get 59.2. Similarly, for 2 we can find out, for 3 we can find out, and for 4 we can find out. After calculating all these values, we'll take approximate a near about value to all these values. So the near to this is 30, we are rounding it off. This is 30, this will be 59, this will be 44, this will be 15, and this will be 2. If you will take total of this will become 150, and in actual frequency also the total is 150. So this is how we fit a binomial distribution to any given data. Next question. If 2% of the books bound at a certain bindery have defective binding, determine the probability that 5 of 400 books bound by this bindery will have defective binding. So here in this case we are given x equal to 5. Okay, because we have to find the probability that 5. We have to find the probability of 5. So x is 5. Total number of items are 400. So n is 400. 2% of books are found to be defective. So probability of defective, because we have to find a probability of defective. So probability of defective items is taken as success. So P is equal to 2 upon 100, which is 0.02. So Q will be 1 minus 0.02, which is 0.98. We have to find probability of 5. So P5 is NC5, P raised to power 5, Q raised to power n minus 5. N is 400, 400 C5, 0.02 raised to power 5. 0.98 raised to power n minus 5 is 400 minus 5 is 398. Now you can see here it is very difficult to calculate such values. 400 C5, it is very difficult to calculate these factorials, and when you multiply these terms, these small numbers, the calculation become very difficult. Even in calculator, it will not show the correct answer. So what to do in such case? This problem is the limiting case of binomial. Okay, and the limiting case of binomial is the Poisson distribution, which we'll talk about in next video. So whenever the value of n, here you can see n is very large as compared to p, value of p is 0.02, which is very small, and n is 400. So as compared to p, value of n is very large. So in such case we will be using Poisson distribution, which we'll talk in our next video. So I hope you have understood everything in this video. If you have any doubt, you can put your problem, you can ask me the questions in the comment section. Thanks for watching this video. Have a good day.